Hey y'all, it's me, Miss B, and today we're talking about limits of quotients. The limits of quotients of two functions equals the quotient of the limits that provided that the limit of the denominator isn't zero. So here's our first example. All that means is we're going to plug in whatever this value is. So I'm going to plug 1 in for x. So I'm going to have 1 to the third minus 3 times 1 squared plus 7 over 2 times 1 minus 5. What I end up with is, well, let's actually write this out a little bit better than that, because this is actually going to be the limit as x approaches 1 over the limit as x approaches 1 of each of these separately. So x to the third minus 3x squared plus 7 and 2x minus 5. So that's really what it's saying. And then because we have two separate things, we're able to plug these in for x. So I have 1 to the third minus 3 times 1 squared plus 7 over 2 times 1 minus 5. Plug that into a calculator, you should get 5 over negative 3. So this is 5 over negative 3. Or negative 5 over 3, I guess I should say. That's a little bit more proper. Alright, so this next one here, again, take the limit as x approaches 3 of x squared minus 1, and the limit as x approaches 3 of x plus 5. So it's just a plug and chug. We have 3 squared minus 1 over 3 plus 5. So that is 8 over 8, which is equal to 1. So the limit of that is 1. Okay, so really where the problem is when we start dividing by 0. So there are 4 different ways we can deal with that. We can make a table, we can simplify by factoring, we can simplify complex fractions, or we can use our rationalizing skills. Okay, here is our first method. It's make a table, and we're going to use this when we can't change the form of the problem into something more agreeable. So for this one here, I'm just going to leave it as is. This does end up factoring, but we're not going to, actually, you know what, it doesn't. This factors to be x minus 2 times x minus, or wait, no. This is x plus 6 times x minus 1. So, oh wait, no, it's not. What am I doing? Two numbers that multiply to be negative 6. Oh, so this is x minus 3, x plus 2. So nothing cancels with the denominator. I'm actually going to change this here so that this says it's approaching 5, because it can approach 2, it just can't approach 5. So that needs to be a 5. So then let's go ahead and make a table. So in the table, I'm going to have 5 in the middle, but that number doesn't work because it's undefined right there, because I can't get 0 in my denominator. So I'm going to put numbers that are really close to 5. So 4.999 is close. Then I'm going to go 1 less than that, and then 1 less than that. So we're really getting super close. Then I'm going to have 5.001, 5.01, and 5.1. So all these values are super duper close and getting closer. So all we do is we plug these into a calculator. We can actually do that in the table settings. You can do that. So I don't know that I have a calculator on here that will do it anymore. Yeah, I don't have a calculator on here, but you can use a table in your calculator. Okay, so when you plug those in, what you should get is we get negative 131.1, negative 1319.01, negative 13991 point. Need to make my pen smaller. 13991.001. 5.001 is 14009.001. We have 1409.01 and 149.1. Okay, so as you can see, these values, if we're just looking here, these seem to be approaching, as they approach 5, a negative number. Okay, they're getting more and more negative as they approach 5. This here, they're getting more and more positive. So if one's approaching a negative and one's approaching a positive, then we have that this needs to go away. If they're approaching different values, then they are not going to have a limit. So, just something to think about there. Okay. So we'll go save that one for class. Now, in the same way, if they were approaching the same number, and it'll be pretty obvious, then we would have something for that. Okay. So this next method is simplify by factoring. So we're going to factor, simplify, get rid of the denominator, nothing too difficult. So this is going to be the same thing as the limit. Let me change my pen size back. The limit as x approaches 5, and then this is going to be two numbers that add to be negative 1, but multiply to be 20, negative 20. So x minus 5 times x plus 4. And I do need to write it as the limit until the very end, until I take that limit. So write it as limit until you take the limit. So that's that. Okay, so then I'm able to cancel these out. And so I'm looking at the limit as x approaches 5 of x plus 4, which is the same thing as 5 plus 4, which is 9. Okay. So with sum factoring, we need to remember that the difference of cubes is going to be the same, opposite, and always positive sign. So we have, I'm actually going to change my size pen here. Oh, this works. So same, opposite, always positive. In the first, it's going to be the cube root of the first term, cube root of the second term. Then I'm going to square this number, put it here. Square this number, put it here. Then I'm going to multiply these two numbers together. And that would be my middle term. Okay, so this factors, we've got the limit as x approaches 3, and if we plug 3 in, we will get 0 in the denominator. So factor the top, difference of squares, x plus 3 times x minus 3. Factor the denominator, so cube root of the first, cube root of the second, same sign, opposite always positive. My goodness. Okay, so square the first term, square the last term, and then the product of the two terms. Okay, then we can cancel stuff out. This cancels with this, and so we're left with the limit as x approaches 3 of x plus 3 over x. I guess I don't need these parentheses. X plus 3 over x squared plus 3x plus 9. So then I'm able to plug those values in. So I have this is equal to 3 plus 3 over 3 squared plus 3 times 3 plus 9. 3 squared is 9. 3 times 3 is 9. 9. So 9 times 3 is 27. So we have 6 over 27. Divide both by 3, we get 2 over 9. Limit is 2 over 9. Okay, method 3 is simplifying complex fractions. So we want to get basically all of this to equal one fraction. Okay, if I plug 0 in, I will get something messed up. So I'm going to move this over because I like working down. Okay, so we're trying to get it to one fraction. So this will be the limit as x approaches 0, and then we want to get this all figured out. So in the numerator, I'm going to take the numerator and then multiply this by x over x, and this one by x plus 2 over x plus 2. So I'll have x over x times x plus 2 plus x plus 2 over x times x plus 2. Don't multiply that out because I can see that something might cancel in the denominator. Okay, so then we have the limit as x approaches 0 of 2x plus 2, adding these together, over x times x plus 2 all over 1 over x. Alright, and that's equal to the limit as x approaches 0. And then I'm going to go ahead 2x plus 2 over x times x plus 2. I'm going to multiply by the reciprocal of the denominator. These cancel, and I'm left with the limit as x approaches 0 of 2x plus 2 over x plus 2. So I'm actually going to take this and move it up here. So I can plug in 0 for x. So 2 times 0 plus 2 over 0 plus 2 gives me 2 over 2, which is 1. So the limit of this whole thing is just 1. Okay. Then we can also rationalize. We want to do that when there's square roots in the fraction. So if you remember, we're going to have to multiply by the conjugate to get rid of that radical. So I'm going to multiply by the conjugate. So if I have x plus 9 minus 3 over x I need to multiply by the conjugate, and I'm multiplying by the conjugate because I can't plug 0 in. So the conjugate is square root of x plus 9 plus 3. Do it to the denominator as well. That way we're multiplying by a form of 1. So the limit as x approaches 0, and so then we have x plus 9 squared minus 3 squared, because this is the difference of squares right there. You can, actually, you know what, let's FOIL it out just so we can clarify. So, FOILing, I get square root of x plus 9 times the square root of x plus 9 minus 3 times square root of x plus 9 plus 3 times the square root of x plus 9 minus 3 times 3, which is 9. That's all over x root x plus 9 plus 3x. Actually, you know what? Yeah, that's fine. No, let's leave it as x times square root x plus 9 plus 3. Just in case anything cancels with the numerator. So then we have limit as x approaches 0. Then x plus 9 times square root of x plus 9 times square root of x plus 9 is just x plus 9. These two are going to cancel, and then I'm left with minus 9. Okay, these 9s are going to cancel, leaving me with a limit as x approaches 0 of x over x times x plus 9 plus 3. These x's are going to cancel, just like I thought, and so then we have the limit as x approaches 0 of 1 over the square root of x plus 9 plus 3. And so then I'm able to just plug in 0. So I have 1 over square root of 0 plus 9 plus 3. So that is 1 over 3 plus 3, or 1/6. So all this work just to get that this limit is 1 over 6. Okay, that's all for today.